Okay, let's start. Um, my name is Alex. I see a lot of friends in the audience, so hello, friends. And today I will be sharing with you some of the problems that we faced when we were building the Kendo UI teams, like when we were styling the components that are part of the Kendo UI product. So hopefully you'll be able to gather some insight from all these problems that we faced and probably evade some of the challenges that really hit us from nowhere. But let me give you some context for those of you who haven't worked with Kendo UI in the past. Well, that's a small fraction of you from what I see. But in the beginning, there was jQuery, and it was good. That's like 8 or 9 years ago when the Kendo UI framework was starting out. And we built the original Kendo UI on top of the jQuery library. So we built the framework along with the single-page application framework, etc. Everything was pretty dandy. And we built the teams specifically for the Kendo UI product back then. Fast forward a few years, and well, the quant-side framework landscape has exploded, and there are many frameworks that are currently used to build front-end applications: Angular, Vue, React. And we built another set of components for each of them, of these frameworks that I've listed on this slide. And when building the teams, we had these, and the styling, we had this problem that we already had the styles made for the jQuery offering, for the product that we were making at Progress. And well, it didn't make sense to just throw it out and start anew for each of these frameworks. So have this in mind for the problems that I will discuss. So our aim was to have this unified team offering that just encompasses all of these frameworks, and that allowed us and our customers to build applications for any framework they want to, and have the same look and feel that they have already used for like years. And this also allowed us to migrate some of our customers who have jQuery applications built for jQuery and with jQuery, and to let them migrate to a newer, more modern framework like Angular and Vue and React. So having a set of styles that let your application look good with while you are migrating your application from jQuery to Angular, that's a really powerful thing, because it lets you migrate just a page at a time, and that's really powerful for most of our enterprise customers who cannot just say, okay, we're just starting a rewrite in Angular or in Vue or in React, and we'll be doing that for the next couple of years, and we'll ship no new features, just the subset of our current features that you already have, our customers. So that would be stupid. So yeah, that was one of our original design goals for the teams. Build an offering that works for every platform and allows us, Progress, to build new offerings for Kendo UI for any new framework that we start to support. So that's the context. So I'll be showing some problems, 3 problems that we faced, the solutions that we explored, and the lessons that we learned, that I learned from that experience. So that the lesson part is really personal in that regard, but yeah, the solutions are quite applicable to many projects. So here's the first problem that we had. So how do we share styles with JavaScript? And why would anyone want to do that? Why would you want to share the CSS, the specifics of the CSS with the JavaScript? Well, it turns out that's a great problem for charts, because our charts are rendered in JavaScript, and that allows them to work with as SVGs or VML. And when we have CSS rules for our other components, for example, the buttons or the grid or the dropdowns, we want to propagate these styles to the charts so that the charts look in a similar way, like consistent with the buttons. So that was our problem, and thinking about it made us realize, well, it's a general problem. How do you encode data in CSS so that it can be read in JavaScript? So how do you move the data from the CSS to JavaScript? And that took me as a very interesting question, because like it was encoding, it was still web, but it's like a very general problem. And I wrote some of my thoughts on it. But basically, this boils down to how do you take the Sass variables that you use, because we are using Sass for building our CSS, and how do you encode these Sass variables into CSS so that they can be read by JavaScript? And a very modern approach for that would be to just have CSS Custom Properties. So that code makes exactly that, and it's like 2 lines of code. We just set the variables into CSS Custom Properties, and we can then read these through JavaScript and have access to the same colors when we are rendering the charts. So that's great, but since we have enterprise customers and they use IE, this is actually not applicable at all in our case. So that caused me to dig deeper into the issue, and you can read about that in the blog post that I linked earlier, but the end effect of that was that it turns out you can really encode JSON into CSS and then read it out of the CSS. Let me explain how this happens. So in CSS, you have this content property, which allows you to write arbitrary content as part of the styling of the site. This is really useful if you, for example, have external links in your website and you want to make this tiny icon next to the link that indicates to users that the link is external. So the content property is really great at that, because it lets you insert arbitrary content. Well, what if this arbitrary content was JSON? Well, why not? And this allows you to place anything you want to inside the CSS and then read it out from JavaScript. So this allowed us to really have the complete theme inserted into CSS and then write it out from JavaScript. And generating this CSS in Sass is literally 10 lines of code, so 5 of which are commands. That's really easy to do. So that made us create JSON in CSS, which is kind of opposite of the current trend of CSS in JavaScript, but hey, that's cool. So the lesson I learned from that is that you should always aim for a single source of truth, because having the styles that control the CSS of your application, change also some parts of your application that are not CSS, lets you have this common mindset about how users should build your application. If you want to style something, just update the styles. That's pretty much it. And that makes it very easy both for internally and externally for developers to customize our components. So it's not only the charts, it's like a lot of the database widgets can be customized through that approach. So having a single source of truth is like the CSS and the SAS theme is really powerful. The second problem that I want to share with you is dependencies. And hey, well, dependencies are pretty much a solved problem in terms of, well, all these package managers like NPM and the building JavaScript. But in terms of SAS and CSS, that's really not the case. So here's the thing, the problem that we actually wanted to solve. So imagine you have an application that has a grid component in it. And this component needs to have the styles for a drop-down list and a button because it uses them internally. So you as a customer of our components, you want to have the styles for the grid and for all of its dependencies, but you don't want to schlep around the styles for the chart, for example, because that would just make the application really large, and that doesn't make sense in your case. So how do you do that? How can you describe the dependency of the styles that are for the grid and for the styles that the grid needs also needs the drop-down list and the button components, but not the chart? Well, it turns out there are modern solutions that allow this, like CSS Modules, but they have some drawbacks for our current use case, because CSS Modules let you have a CSS file that gets converted so that it contains only style specific to your component. But for example, the grid needs to have a border. Okay, that CSS class that sets the border will be preprocessed and will be applied only to the grid. So it will create unique classes all around your code base that will allow them to not clash with anything on the page. That's great. That's a great feature. However, when you have multiple frameworks that need to work with the same models, you need to make them sync with these models. So our jQuery offering had to be rewritten so that it worked with CSS models. So that didn't make sense for us. Also, when you offer support to your customers and when you want to make quick workarounds for issues, as we kind of need that in our support service, these unique classes that CSS modules create are not the thing that you want to, because you want to target specific elements on the page, and having unique classes doesn't say much about them. So CSS modules, great solution, but not to our problem. And that's the solution that we came up with was actually a very elegant and very minimalistic SAS solution. Turns out if you have a way in any language to make it so that a file doesn't output anything and doesn't process based on a condition, you can build a whole dependency module system around that. Because if this model, if a file has been loaded already, you don't process it again. So that's an idea that just allows you to build a module system. And I took the inspiration for this from from the C++ module system. Well, not really module system. It's a bunch of defines and preprocessor directives. But hey, it works. And it really works pretty great because it allows you to specify dependencies, and it gives our customers the possibility to just create custom style sheets based on what they use. They can say, I use a grid and a scheduler, and that would bundle up the styles in the correct order in their custom style sheet. So the lesson I learned from that experience was that, well, you should get inspired from other solutions, like the C++ thing with the defines. Well, it's archaic, but still it works today in our code base. And one shouldn't be afraid of taking the approach and making it into something new. So that's what I learned from that. The next problem that we faced, the third and last problem that I'll show you today, is regressions. And regressions make everybody sad, especially enterprise customers. They're really not keen to breaking styles in production. And that's really a problem that can be solved through both workflow and code. So you have these two components that you can, like levers that you can work with. So our first solution to that problem, whoops, sorry. Our first solution for this problem was to have code reviews across the team project. And that's pretty great. I really like having code reviews, and they let us synchronize on the features that we have to ship. They allow us to teach new team members on how to work with the code base, what to evade and everything. But there's really a consensus of making being wrong together. Because even the best team member doesn't have a rendering engine in their head. And it really doesn't prevent all regressions just by having a code review process in your team. So the second solution that we export and that we implemented was custom lint rules. So that is, again, a way to improve the code base and to prevent some of the problems that people that can go to production and turn into regressions. But it's more of a nitpicking solution. So it really allows team members to focus on what the code really does, instead of just saying, oh, well, you used 2 white space characters here instead of a tab, and that's bad. So it eliminates that clutter, but still it doesn't prevent all regressions that could happen. For specifically, the custom lint rules could prevent regressions in terms of making some weird use cases less likely to occur. For example, in SAS, you have this thing that if you have 2 variables that are in different units, like 100% and 10 pixels, and you subtract them one from the other, you get a result in one of the units, which is not great. And that could lead to regressions in production. So a custom lint rule can and does prevent the regression by just enforcing the style that's here below. and that works. So the next solution that we tried and that really minimized the regressions we had in production is implementing visual tests. And that allows us to just see what the CSS will look like when it is rendered after, when the new changes are applied and rendered. So that has great support in GitHub and GitLab, especially in GitLab, because they allow you to place comments on different parts of the image. So let me show you how this works. So a developer that writes code, CSS code, commits the CSS code into the repository. Then the build machine, the CI server, will takes the CSS code, builds it, and renders how it looks, and commits the screenshots into the pull request on GitHub or GitLab. That gives the reviewer a way to see what the changes actually mean, and that really makes the review very easy, because you don't have to think, okay, this CSS property turns some button green, and that's not what we want. You actually see exactly the effects that that will be applied to the production code. And this gives feedback both to the reviewer, so that she can think about the issues that have been fixed, and to the developer, so that she can look at the CSS that has been created and see if there are changes in some parts of the code that she didn't intend to change. Here's an actually how it works. So this is a GIF recorded from the GitHub interface, and it's just a before and after screenshot of the same interface. And as you can see, the borders down there have been added, so that they are on the image on the right. And this gives the reviewer exactly the context that they need. They can say, okay, that works great for me. And the styles are okay because we've already passed the lint rule check. So let's ship it. And you may have noticed that in order to create these screenshots, you need to have some markup along with the styles. And that for us was a novel idea, because most of the frameworks, like we have 4 different code bases of components, and they live in different places, and the styles are in a different repository. So having HTML in the repository for the styles allowed us to have this type of blessed rendering. What does blessed rendering mean? It means this is the rendering that the styles have been written for. And if you want to change the rendering of the component inside all of these sheets, you can do that, but it has to pass the same pull request review approach. So this gives us a way of consensus between teams, because the HTML is along with the CSS, and if one product needs some changes, they need to happen through the teams first. So that's great, because also if you decide to make another set of components, for example, for a new future framework, let's call it Angular TS, because it will be completely different from Angular and AngularJS. And you can just take the rendering and apply the same styles, and you have a new framework built with the same styles. So the lesson I learned from implementing these three solutions was that one has to use short feedback loops, and this makes it for a great experience for both developers and reviewers. And more generally, it made me believe that CSS can be tested too. So you can have the same process that most people are used to have for, say, JavaScript or TypeScript or C# projects, but you can have these processes for CSS. They're different because CSS is different. It's a visual language, but still they can be applied to the same to this language. So here are the lessons that I learned from this. I used a single source of truth that really that made it easy for everybody to think about the styles as a coherent thing and not depend on different approaches for different frameworks. Get inspired by other solutions like the C++ hack for defining for module system and implement them into your workflow, and use short feedback loops so that you can develop your code more confidently and faster. And this all boils down that CSS is code too, and you can have the same approach to developing it as you have with other different languages. So thanks, and yeah, that was from me. A bit short of the time, but yeah. If you have any questions, I would be glad to answer them. Yes?
I would like to ask, how do you automate the comparison between things? I mean, like, do you create an HTML with, like, do you have a kind of a sample project which showcases how things are used, and you?
Mm-hmm. So the question is, how do we create screenshots based on what do we create on the screenshots? Well, so we have a repository that hosts our CSS code, and in that repository we have the HTML that's required to make these screenshots. So you have this blessed version of the HTML. It is different test cases. You can think about the HTML as a test case, just like a unit test in, say, JavaScript. Having this test case allows you to take a screenshot for it and commit it into the repository. So this is what the CI machine does. GitLab and GitHub have the interface for comparing these screenshots. So you always have this up-to-date look of what you're styling committed into the repository. This could lead to size problems, like having too many images in the repository, but this could be solved by the Git LHS for the large file system support, LFS. Which allows you to host images on a different server.
So do people commit the images, or are they generated?
They're generated by the build machine. The cool thing about this is that you control where the images are generated, so you don't have this, like, this image was created on a Mac, or this image was created on a Windows machine. You have this machine that commits the screenshots, and you just see them as part of the pull request. So this can be reviewed by the reviewer of the code, and yeah. So let me just. Oops. That's so the CI step of this this is what creates the screenshots and commits them to the repository so that they are visible to the reviewer afterwards. Does that answer the question fully?
Yes.
Okay, cool. Sure.
All right, so I have this question. We talk about this blast HTML.
Mm-hmm.
So how is that used from Angular, and jQuery and the other framework implementations of the UI
Mm-hmm.
to keep in sync with the code?
Mm-hmm. So the question is, how do we keep the blast HTML in sync with the different frameworks?
Vice versa.
How do we keep the framework source synced with the blast HTML version? Well, we don't have automation for that currently, but this could be automated because you already have the structure that you want to, that you need to follow in the blast version of this. That's the blast HTML. And you can just test if for example, Angular components match that structure for the same set of data. And this, I should probably reiterate how good the blast structure is, because that made us document how we build these components. So you have this blueprint for building new components that really shines when you create a new component framework.
So if I'm building a grid, I can just render it and then diff with the blast HTML and see that's
Yeah. Okay. Any other questions?
So how many screenshots are generated per commit?
All of them. So you really want to see if committing a fix for, yeah, sorry, I should repeat the question. How many screenshots are created per commit? So once the code is pushed to the server, all of the screenshots are created, recreated. And just the ones that differ are part of the commit. So there's some logic that tests if they are exactly the same. This allows us to verify that a change in the, say, the grid component does not affect, say, the scheduler component. So you have this verification of integrity of the whole suite. And that prevents the regression. That actually prevents the regressions. So, well, okay. Thank you for your attention, and I hope you learned something that could help your styling process in the future.